Welcome to Module 2. So, I've actually already taken this entire video, and this upsets me because I've done everything. Like, there's already examples and stuff, and I'm gonna use them again anyway, but I'm gonna show you anyway because I'm pretty proud of myself. It's the Friday before school starts, the classroom is officially ready, and I have to make this video again instead of making another video. Okay, lesson 1 is why things move around. The whole key to this is learning about geometry and learning about congruence. You learned about congruence last year in 7th grade math. Congruence means that they are going to stay exactly the same. Okay, so exactly the same. So what this is asking us to do is tell me from this figure to each of the other figures what is happening. So what I've already done in the first video that didn't save for some reason is I drew an outline around this figure. I now have this figure on my tracing paper. So what do I need to do in order to get this figure up here? Well, if you say, hey, Mr. H, you just have to slide it up. Yeah, you're right. Now my question to you is, are those figures congruent? And we can check it. How are we checking it? Well, I had my tracing paper on the original. I traced it, and it matches up perfectly with what we're going to call a translation. When it moves and it doesn't change orientation, it is called a translation. More specifically, it's called a rigid transformation. Transformation are all types of movement, but it's rigid because it didn't change shape or size. Okay? So now we're back here. Thank you. So now we're back here. There's our original. How are we going to get to 2? Well, let's try to turn it. Turn it. Turning it doesn't seem to do anything. So what do we have to do? Well, this was at the top, it has to be at the bottom. So let's flip it. Oh, that's still a rigid transformation because it stayed the same size and shape. But when we flip it, it is a reflection. So it's still a rigid transformation. All the movements are called transformations. Rigid because it didn't change shape or size, but this is a reflection because we had to flip the figure. There is a line of symmetry because reflections are symmetrical, but that's fine. Last but not least, how are we going to get from here to that guy? Well, it's not a translation because it wasn't a slide. It's not a reflection because it did not turn over. But here's where it started. Wait a minute. If I keep turning my paper into a different orientation, oh, lo and behold, I have the same exact figure. So once again, that is a rigid transformation. But when we turn the figure, that will be a rotation. Like you rotate a doorknob, we rotate the figure. So again, there are 3 rigid transformations. 3 rigid transformations. A translation, a reflection, and a rotation. Those are all congruent. Rigid transformations are congruent. Congruent means same size and shape. So given 2 segments, segments is a key word here. Why? Because the segments have end points. And really, if we're being specific, this should be segment A, B, and segment C, D. Okay? Sometimes I'm smarter than Engage New York. Have to have the proper notation. But segments have 2 endpoints, which means they stop. A ray stops at one place, goes forever in the other direction. If they go forever in both directions, they are lines. So, it wants me to know, how can I tell if this is the same size as this? And some of you might be saying, okay, well, I can get a pencil, and I can lay the pencil down, and I can say, okay, right there, perfect. Looks good. Yeah, we can eyeball test it, but there's no reason to just do an eyeball test. We can come here, grab this paper, and put 2 points where the end points are at A and B. Okay, if you can't see those, let me make them a little bit bigger. So we have endpoints at A and B. So what can I do in order to see if this works? I can take this same piece of paper, bring it over here, and say, okay, are those the endpoints? Well, yeah, those are still the same endpoints. So are these congruent, which means they have the same size and shape? You should say, yeah, Mr. H, they are congruent. Now, there's some things in here that we haven't talked about because there was only 2 examples in this entire lesson that are important. Okay? I'm going to come down and I'm just going to talk about this. Don't worry about reading it. The key, though, is this word prime. Okay? So if I have an original figure that is triangle ABC. There's triangle ABC. Can we see that? Yeah, we can see that. If I translate it, which means I'm going to slide it up here, what are we going to label the new points? To know that this is the translation, we keep the same letters, but we put these little apostrophes up there. Those are called primes. Triangle ABC, triangle A prime, B prime, C prime. What if we translate it again? Well, if we translate it again, instead of having 1 prime, it would have 2. We would call this triangle A double prime, B double prime, C double prime. Translations are a rigid transformation or a rigid motion. Rigid meaning stiff as a board. So if I want to move, I can't move. I wish I had somebody in here to lift me up because to rotate, my whole body would have to stay in line and everything would move at the same space. But if I did that and I tried to jump, I'd fall, which some of you would probably enjoy. If I had a reflection, then I'd go from here and then my feet would be up in the ceiling and you'd see my head upside down. I'm not going to do that. So we have 3 rigid transformations. A translation, which just slides it. So here's my marker. It doesn't change from having the cap this direction. We have a rotation, which is a rigid transformation. Boop, 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 boop. Then we have a reflection. The reflection is like a mirror. Think that you have a mirror in the middle. This is what you're seeing on one side. The person on the opposite side seeing the same thing, but like in a mirror. Okay? So, 3 rigid transformations. And done. Hopefully it saves this time.